We are given the vector equations of two lines, and part A, we need to show that these lines are skewed. To show that two lines are skewed, we need to show that they do not intersect and they are not parallel. So first, we need to show that these two lines are not parallel. Then for this first line here, let's find the direction vector of this line. This part gives us the direction vector of the line. So we have vector 2, minus 1, and 3. And for the second line, this gives us the direction vector. And since we see that the direction vector of the first line cannot be written as a constant multiple of the direction vector of the second line. So k is any real number and k is not 0. These two are not constant multiple of each other. That means line 1 is not parallel to line 2. We now need to show that these two lines do not intersect. Let's look at line 1. From line 1, equating the components of vector I, we have 1 plus 2s. Equating the components of vector j, we have y equals 3 minus s. And equating the components of vector k, we have z equals 2 plus 3s. That will give us the parametric equations of line 1. For line 2, equating the I components, we have x equals 2 plus t. Equating the j components, we have y equals 1 minus t. And equating the k components, we have z equals 4 plus 4t. Now, if we equate these two, we have 1 plus 2s equals 2 plus t. Rearranging, we have 2s minus t equals 1. Let's say this is equation number 1. And from these parts here, equating these two, we have 3 minus s equals 1 minus t. So that minus s plus t is negative 2. That is equation number 2. Don't worry about that. So for these two equations, we can solve equation 1 and equation 2 simultaneously to find the values of s and t. 2s minus t equals 1, and minus s plus t equals negative 2. We can add these two equations to eliminate t. So 2s minus s is s, and s is negative 1. And to find the value of t, we can substitute s equals negative 1 into equation number 2. You can substitute into equation number 1, it doesn't matter. So when s is negative 1, negative s, that will give us 1 plus t equals negative 2. And we have t equals negative 3. To show that if these two lines intersect, they must have the same z coordinate for these values of s and t. So from line 1 here, z is 2 plus 3s. S is negative 1. So this will give us a z coordinate of 2 minus 3, which is negative 1. And for line 2, the z coordinate is 4 plus 4t. T is negative 3. That is a negative 8. These two are clearly different. So if these two are different, we say that line 1 and line 2 do not intersect. So if these two lines are non-parallel and non-intersecting, we say that line 1 and line 2 are skew lines. Part B, we need to find the acute angle between the directions of the two lines. So we just need to find the acute angle between the direction vector of line 1 and the direction vector of line 2. To find the angle between two lines, we can use the definition of the dot product. The dot product of line 1 and line 2, the direction vector, that is given by the magnitude vector of the direction vector of line 1, magnitude of the direction vector of line 2, times cosine of the angle between these two direction vectors. So direction vector of M1 is 2 minus 1, 3. We dot with the direction vector of line 2, which is 1 minus 1 and 4. The magnitude of line 1, we have 2 square plus negative 1 square plus 3 square. And the magnitude of the direction vector of line 2, we have the square of 1 plus the square of negative 1 and the square of 4 times cosine theta. The dot product over here is 2 plus 1 plus 12. And this is 9, 10, 14. That would be square root of 18 cosine theta. That will give us 15 equals square root of 14, square root of 18 cosine theta. Then we say that cosine theta is 15 over square root of 14 and square root of 18. Since this is a positive value, we do not have to use an absolute value. Theta is given by inverse cosine of 15 over square root of 14, square root of 18. And that is 19.1 degrees.